This is a presentation of 8th grade, Chapter 4, Section 1 notes entitled Exponents. We'll go ahead and start off with the definitions here. Exponential form. A number is an exponential form when it is written with a base and an exponent. A number is an exponential form when it is written with a base and an exponent. An exponent is the number that indicates how many times the base is used as a factor. An exponent is the number that indicates how many times the base is used as a factor. Base, when a number is raised to a power, the number that is used as a factor. Base, when a number is raised to a power, the number that is used as a factor. And a power, a number produced by raising a base to an exponent. A number produced by raising a base to an exponent. All right, so let's go ahead and skip down here and look at question number 2, where it's asking us to simplify 3 to the 5th. We're not going to solve the problem yet, but I want to make sure we have clear in our head what these different components are that we've just defined. That expression there is 3 to the 5th. 3 to the 5th is a power. That entire thing there is referred to as a power. And there's a couple parts that make up a power. There's the concept of a base. The base is the big number, the number 3, and an exponent, that's the little number, in this case 5. Remember, hopefully you remember, a power is a repeated multiplication question. So when we're talking about 3 to the 5th, that means I'm going to be multiplying 3 together a bunch of times. And the number of times that it's going to appear in the problem is what the exponent tells us. So since 5 is the exponent, that means 3 is going to be multiplied together 5 times. So there's going to be 5 3's in that multiplication problem. So what they do here in example 1 then is they actually go the opposite direction. They actually ask us to start by writing in an exponential form. And they've given us 4 times 4 times 4 times 4 there. So we have to see two things. We're looking for the number that we're multiplying together and how many times it's in that question, because that's the two components that are going to help us write our power. Well, 4 is the number that we're multiplying together there over and over and over again. So 4 is going to be the base. Again, that's the big number. And then the exponent is how many times that 4 appears in the problem. Well, as you can see, there are 4 4's in this particular question, and that's why the exponent is 4. 4 to the 4th is what this is in exponential form, and we're done. We're going to do the same thing in B. Now, don't let the fact that there's negatives in B throw you. It doesn't matter that there's negatives in B. They can be positive, they can be negative. It's still the same thing when we're talking about the base. So we've got negative 6 being multiplied together a bunch of times. So that's going to be the base of my expression, negative 6. And again, the exponent is how many times it's being multiplied together. Well, as you can see, we've got 3 negative 6's here in this problem, and that's why the exponent here is 3. Negative 6 to the 3rd power is the same as negative 6 times negative 6 times negative 6. We'll go down and look at the bottom here where they're asking us to take 3 to the 5th now and simplify that. So they're really just asking us to reverse what we've just done. Well, we know 3 to the 5th means I'm going to use 3 in a multiplication problem 5 times, or there's 5 3's that are being multiplied together. So this is what it is written as a multiplication question, but this is not fully simplified because we can actually multiply that and come out with something there, and that would be equal to 243. The time this would not be simplified, or this rather would be fully simplified, is if this was variables. If it was x to the 5th, you could write x times x times x times x times x, but that's it. There's nothing else you could do with it beyond that. But in this case, since it's numbers, we can multiply those 3's together and get 243. Now, here's negative 3 to the 5th, so very similar question. As you can see, we're multiplying together negative 3 a bunch of times, specifically 5 times here. So in this case, I'm going to multiply these negative 3's together. Now, what we have to remember is that 2 negatives are going to make a positive. So here we've got a negative and a negative. That's going to make positive. Then I'm going to multiply that by a negative, which is going to make it go back to negative, because a positive and a negative make a negative. Then I'm going to multiply by another negative, which is going to change this back to being positive, because another negative with a negative makes a positive. And then a positive and a negative is going to make a negative. As far as the numerical value, it's the same 3's being multiplied together, so it's still 243, but it's now negative 243 instead of positive 243. All right, so as we continue on down here, we're going on to example number 3, where they're going to have us working with the concept of order of operations in exponents. When we studied order of operations earlier this year, that's the one thing we really didn't spend any time on because we had not seen this chapter on exponents. Well, now here's the chapter on exponents, so we can spend some time with it. They're asking us to evaluate x times, and times is shown in the form of parentheses, y to the x minus z to the y, close those parentheses, so ending the multiplication problem, plus x to the y. And they tell us that x is 4, y is 2, and z is 3. So remember, what that means is anywhere you see an x, you're going to change that into a 4. Anywhere you see a y, you're going to change that into a 2. And anywhere you see a z, you're going to change that into a 3. And those are the changes that they make there on that first line of work, where they're saying substitute 4 for x, 2 for y, and 3 for z. Okay, so at this point then we're going to go ahead and start solving. Remember, the first step in order of operations is not actually exponents. The first step in order of operations is actually parentheses. And as you can see, we do have quite a few things there inside parentheses, so these are going to be able to get done first here. And as you can see, those are both exponents inside there that they're going to do. We've got 2 to the 4th. So remember, that means 2 is going to show up in a multiplication problem 4 times, and 3 to the 2nd power. So 3 in that multiplication problem 2 times, or 9. So that changes into 16 minus 9 inside the parentheses there, and they fully simplified that. And they can, at the same time, since it's outside and it's not going to affect anything, they're also going to go ahead and take care of 4 squared. 4 squared would be 4 times 4, which is 16. All right, going back, because we've still got some subtraction to handle here in the parentheses. Again, this plus 16 at the end, they're just kind of dragging it down. They really should have done it later, but it's not going to impact anything then with them doing it so early. 16 minus 9 is going to change into 7. So this is 4 times 7 plus 16. And then 4 times 7 multiplication becomes before that addition. So 28, and 28 plus 16 is 44. All right, let's go ahead and take a look at the next question here. The next question is asking me to use the expression half times n squared minus 3n to find the number of diagonals in a 7-sided figure. Remember, diagonals go from vertex to non-adjacent vertex in a shape. So if we were looking at a square, and I said draw the diagonals that go from this corner, well, the diagonal is going to go that one because that's the only corner that's not next to this corner. This corner is next to it that way, this corner is next to it that way, this corner is not next to it. We'd have to go to another corner to get there. That's how we know it's not. These ones are not, and this one is a diagonal. That's all a diagonal is. So they've proposed a formula there, and we're going to use that formula where n represents the number of sides to find the number of diagonals in that 7-sided shape. So this is a matter of me changing n into 7 and then solving. So this is, again, order of operations. As you can see, when we make that change, we've got parentheses here, which are going to have to get tackled first. So you've got that 7 squared, which is 49, and 3 times 7, which is 21. So you've got 49 minus 21 there, which is going to change into 28. And now that we've tackled all the parentheses, we can go back and get the half, and that's going to give me 14. So there are 14 diagonals in a 7-sided shape. Now, number 1 here in the check it out is a little bit different than the question we did earlier. They're asking me to write this in exponential form, and they've given me 7 times 7 times b times b. We really haven't done a lot in this presentation or in this section with variables and exponents, but it doesn't really function any differently than the numbers. It's just they actually simplify a little bit easier because we don't really need to multiply. In the front of that question, number 1 there, we've got 7 times 7. Well, 7 times 7, that's 2 7s, or 7 is being used in the multiplication problem 2 times. So that's going to be 7 squared. And with the b's, we have the same thing happening because there's 2 of them. So that's going to be b squared. Now, that is written in exponential form, but usually we would not write the numerical value, as you can see from looking at the answer there, with the exponent as well. We're going to convert that into its numerical value when we actually multiplied it. 7 squared is equal to 49, of course. With b squared, there's nothing else you can do with b squared. If you want to separate b squared, you're going to go back to where we started with b times b. So b squared is where it ends. 7 times 7 times b is the same as 49b squared. Now, number 2 gives us some good practice with negatives, also something we really haven't done a lot of, at least in this context. Notice what this says. It's a little bit differently than what you might be thinking. It's negative, or opposite really, and then it's got parentheses around the 5 squared. We have to do what's in parentheses first, but notice the negative is actually outside of the parentheses here. Because the negative is outside of the parentheses, we're not actually squaring it as a negative. We're just squaring 5 here. Well, if I square 5, that's 5 times 5, which is 25. And then because there's that negative in the front, which means opposite, that's going to make me flip the sign and write this as negative 25. Now, some of you might be thinking, well, wait a minute. If I take negative 5 and square it, why wouldn't it be positive 25? You're right. If I took negative 5 and squared it, it would be positive 25. Unfortunately, negative 5 squared would either have to look like that or like that, and that's not what we have here. We have the 5 being squared just because that's what's in the parentheses. That's how I get my 25, and then the negative being out front changes the sign when we're all done, and that's how we get negative 25. Number 3, we're going to evaluate z minus 7 times, which is showing up in the forms of parentheses, 2 to the x minus x to the y, close the parentheses. And we're supposed to let x equal 5, y equals 2, and z equals 60. All right, so we'll plug in some numbers here. Z is supposed to be 60. And then it's minus 7, parentheses. All right, now it's 2 to the x, so that's going to be 2 to the 5th because x is 5. Minus x to the y, 5 to the 2nd. All right, so as you can see, we've got quite a bit to solve there in the parentheses, and of course that's going to have to get done first because order of operations says parentheses first. So I'm going to have to do 2 to the 5th first. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So 2 to the 5th is going to change into 32. And then you've got 5 squared, which is a shorter multiplication question. 5 times 5, which is 25. Okay, parentheses still there, so we're still going to have to take care of that. 60 minus 7 is going to stay, but the inside of that parentheses is 32 minus 25, which is 7. Well, now I'm choosing between subtraction and multiplication. Which one to do first? We know we're going to have to do the multiplication first, so that's going to be 60 minus 49, and 60 minus 49 changes into our answer that we see pre-printed, 11. In the final question, we're asked to use the expression half times n squared minus 3n to find the number of diagonals in a 4-sided figure. Remember, n represents the number of sides, so wherever we see an n, we're going to change that into a 4. And this is continued practice with the order of operations using exponents. Again, my rules of those order of operations are going to tell me I'm going to have to tackle all of that parentheses work first. And of course, as you can see, we've got an exponent in there, which we're going to do first, and then the multiplication. Remember, after that, after we touch on that parentheses rule, they follow the rest of the rules. So exponents first, then multiply, divide, then add, subtract. So the 4 squared is going to change into 16. Then I can do the 3 times 4, which is 12. And now it says 16 minus 12. Well, 16 minus 12 is, of course, 4. So they're asking us to find half of 4, which is 2. So a 2-sided figure, a 4-sided figure has 2 diagonals in context.